Hello, everybody. In these problems, we are estimating limits numerically. So what is a limit? Well, it's an important concept in calculus. And basically, what it lets you do is to look at the behavior of a function, not at a particular point, but as it gets near to a particular point. Why you would want to do this is that sometimes there are functions that don't have every point defined, but they have all the other points right up to that point defined. So for example, here we have f of x equals x squared. This is a continuous function. The limit of any point on here is just going to be the value of the function. So for example, the limit as x approaches 0 of this function, we could look at it, what is y approaching as it gets closer and closer to 0, both from the left and the right, and the answer is 0 because the point 0, 0 is there. However, there are functions that have undefined points, like holes in the function. So you couldn't just ask yourself, what's the value of this function where x equals 1, because it's not defined. But you can tell from the graph, as you get closer and closer from the left and the right to a value of x equals 1, the y value, the value of the function, is also 1. So the limit of this function as x approaches 1 equals 1. And there are other functions where, for example, this one is also undefined at 1. What is the limit of this function? What value is the function approaching as x approaches 1? Well, this is an odd case, but you would examine it by looking at the behavior of the function as you get closer to 1 from the left and closer to 1 from the right and see what's going on. I'll let you ponder about that one. I'm not going to give you the answer to that one. Sometimes we don't have a graph though, and we need to just figure out the limit numerically. And this is kind of a way you can just plug in values, crank them out, and look at the results and see, oh, obviously the limit is approaching such and such a number. So here we have a chart. It's got x values and then the value of the function itself. This is the function. And they've plugged in those values and cranked out the numbers of the function. So we're trying to get closer and closer to 0 because we want to figure out the limit as x approaches 0. So first, this person plugged in a negative 0.5 and got a 10.5. Then they plugged in a negative 0.1, much closer to 0, and they got an 11.7. Then a negative 0.05, and they got 11.8. And now we're going to plug in a number much closer to 0, negative 0.001. That's from the left. They're doing the same thing from the right. They plugged in a 0.5, a 0.1, a 0.05, and we're going to plug in a 0.001. The way to do this is not too tough. You're just going to plug in this value, this x value, in the function. So I'm going to put x in there and calculate it. And let's see, I did that calculation and I got for this one 11.997. I guess they want 4 digits, 9970. I did the same thing with a positive 0.001 and I got 12.0030. Now, you should just be able to tell by looking at these numbers what value this is approaching. It's getting closer and closer to 12 from the left, closer and closer to 12 from the right. So I think you can reasonably say the limit of this function at x equals 0 is 12. Okay, let's look at another one. Same kind of thing going on. We have the limit as x approaches 5 of this function. And let's see, they've done a bunch approaching from the right. They put in a 6, a 5.1, a 5.01, a 5.001, and we've got 0.63, 0.69, 0.699, 0.6999. So already I've got a good guess of what this is going to be. I think it's going to be 0.7. From the right, they plugged in a 4, they got 0.77, then a 4.9, 0.707, and 0.499 and 0.4999, much closer to 5. We're going to have to plug in ourselves. So let's see, I've done that calculation, and the 4.99 gave me 0.7007, and then the 4.999 gave me 0.700, and that rounds up to 1. Yes. Okay. So as you can see from the left and from the right, these are all getting closer and closer to 0.7. So I think we can say that that's what the limit is going to be there. There are other ways to calculate limits, but this is something you can do with any function you have. Plug in values approaching that value that you're trying to find the limit of, and then see what comes out and what a number it appears to be approaching. All right, that's a little bit of work with finding limits numerically.